multiplying them. But before we talk about multiplying them, let's review simplifying them. Because I think if you understand simplifying, I think the multiplying of them will make life that much better. If you have the square root of 90, okay, the square root of 90, which is not a perfect square, there's no same number times itself that'll give you 90. How do we simplify that? What do you do, Kala?
Like the tree thing, which you could be like 30 times 30.
Okay, we prime factorize it. Okay, the tree thing is what Nikki said, and she said the square root of 30 times the square root of 3. This one you can stop with, but 30 can be broken down into the square root of 3 times the square root of 10. Stop with the square root of 3, and the square root of 10 can be broken down into the square root of 2 times the square root of 5. Did I do that right? Okay. And then once you have that all broken down, you end up with the square root of 2 times 2 square roots of 3 times a square root of 5. What do you do then? As a little review here. Corinne Shellhammer?
You cross out both the threes and make it just a regular.
You look for pairs. You come up with 2 identical ones, they cross off and give you a normal non-square root number. Okay, and then these 2 here, you have to remultiply again. So 3 times the square root of 10 is the same thing as that, we just call that simplified. Now today, what they're going to ask you to do is they're going to ask you to take something like this, the square root of 3 times the square root of 12. Okay, now, you are allowed to multiply square roots together. I mean, you can multiply the square root of 3 times the square root of 12, but the point I'm going to make to you is this. What's the point of multiplying them together if in the end to simplify you're going to break it back down again? Well, this one's a special case one. Lauren says, well, this one's going to give you the square root of 36, which is 6 to begin with. But I'm saying, you know, if you're not that quick with math, what's the point of multiplying this only to break it down again? Or maybe it would help you just to think about it like this. Break it down right away. What's the square root of 12? It's the square root of 3 times the square root of 4, which is that times that. And then you can simplify it from there. 2 square roots of 3 give you a normal 3. 2 square roots of 2 give you a normal 2, and the answer is 6. And in this case, Lauren, yes, I would go with that, where square root of 3 times square root of 12 is the square root of 36. If you can recognize that that's a perfect square, then by all means that's good. But there may be problems that maybe look a little bit more like this. The square root of 42 times the square root of 24. Lauren Franklin, what do you got with that one? Huh? You gonna throw that one at me? What's that? Square root of what? I mean, Lauren, I get my Laurens confused. What's that one, Lauren? You got that one?
No.
Yeah, I don't know. And what I'm saying is this, children. Okay, is there a point in multiplying 24 times 42, getting your answer, you know, getting your answer, which is, what is it, 1008. You get the square root of 1008, and then you have to break it back down again to figure out what times what gives you that. I'm saying there's no real point in multiplying it because you eventually want to break it down into its prime numbers anyway. Okay, so you take the square root of 42. What times what gives you 42? Square root of 6 times the square root of 7. What times what gives you 6? Square root of 2 times the square root of 3, so you can stop with that. What times what gives you the square root of 24? Square root of 6 times the square root of 4. Square root of 2 times the square root of 3. Square root of 2 times the square root of 2. So I've got all of these square roots things to deal with. What do I end up with? How many square roots of 2? 1, 2, 3, 4. 4 square roots of 2. 1, 2 square roots of 3. And 1 square root of 7. And what do you get if you simplify that? A normal 2, a normal 2, a normal 3, and a square root of 7. Which ends up being what? 4 times 3 is 12 times the square root of 7. Now, are there quicker ways to do that? Well, for those of you that in the mathematical world where this kind of comes a little bit easier to, if you look right here at this level right here, what would you notice? You got two identical square roots of 6, so you could have crossed those off and got, and then your normal 6, you have the square root of 4, which is 2, and then this would be the only thing that doesn't really simplify. So you still end up with 12 times the square root of 7. What's that? Well, if your mind catches it at this level and it makes sense to you, then by all means feel free to stop at that point. But if that's still a little fuzzy to you and you need to break it all the way down to its bare minimum, then that's what you gotta do. Okay. One more, just because I know you're very excited about this. 3 times the square root of 6 times the square root of 15.
What's the number of 15?
That is 15. What's it look like?
But he said
It's 9 times the square root of 10.
Well, just know that this normal 3 just hangs around there. You can't really do anything until the end till you get some other normal numbers. The square root of 6 breaks down to the square root of 2 times the square root of 3. 15 is the square root of 3 times the square root of 5. And then you can work your magic from there. 2 square roots of 3 give you a normal 3. These two don't break down with anything, so you remultiply them to get the square root of 10. And like Jeremy said, since he looked in the book, it's 9 times the square root of 10. Lucas Esmanuel. What's that? The square root of 2 didn't have a friend, and the square root of 5 didn't have a friend, so you remultiply them together. 2 times 5 is the square root of 10. If they don't combine, if you don't have doubles, then you have to remultiply. All right, one more for you to try.
no more in the book.
The answers won't be there, Schwartz, so don't
No.
You know how
I'm gonna look for a hard one.
square root of 100 times square root of 100?
What about 5 the square root of 3?
Yeah. But they it's not the square root of 5.
Square root of 8 times the square root of 5. Tell me what that simplified would be. Square root of 8 times the square root of 5. If you break it down, you end up with the square root of 2 times square root of 2 times square root of 2 times square root of 5. So Austin says that would be, now you have to be careful here, 2 square roots of 2 end up giving you just a normal 2.
Oh my god.
Wait, was Schwartz wrong?
Oh, I did.
Yeah!
Look at my answer.